Yeah, so most of my career has been in kind of two big pockets. There's like application security, which most of you folks are probably doing application security, and I've done a lot of build tooling, which if you think about it are kind of the opposite ends of the spectrum until you start thinking about how internet connected your builds are, right? Everybody's build here connects to the internet or some sort of service to download artifacts or whatnot, right? That means there's some kind of security involved. So that's how I got involved with security. And I'm a beekeeper. So the last few years I've been keeping bees. And if this past year is any judge, I'm a horrible beekeeper. But anyway, so I tell you all this just so you know what formed my biases. Like everyone has their own opinions. These are the frameworks and tools that I've worked on, and that's kind of where my biases lie. All right, so is this a surprise to anybody? No? All right, so we know this. All software has bugs. It's expected. In some cases, it's what keeps us employed, right? We also all know that security is hard. But somehow we all expect our software to be free of security bugs. Right? That's just not going to be the way it is. All right, so today we're going to talk about a few different things. What is a vulnerability? What responsible disclosure is, why that's even important, how to report vulnerabilities. We're going to chat a little bit about Log4Shell. I'm not going to get into too many details. I'm sure everyone here has heard all they wanted to hear about Log4Shell at this point. And then I'm going to leave you with a few tips on what you can do with your projects. My main goal here is I would love to normalize vulnerabilities. So obviously, I'm not a lawyer. This is not legal advice, right? I know in years past, folks have been worried about, fear of retaliation if they go report security issues. I'm not worried about those things. I think as long as you handle these types of problems and report things correctly, this is a non-issue now. But I probably still wouldn't call up, the CEO of a mom and pop shop and explain a vulnerability that way, right? There's a time and a place for things. All right, so what is a vulnerability? Right, so this is what the Oxford Dictionary has to say. It's the state of being exposed to an attack. So it goes on to say physically and emotionally, and this is what Wikipedia has to say, talking about computing. So it's more or less the same thing. It's a weakness that can be exploited by an attacker, right? Except for maybe the emotional part, they're the same thing. But when issues get reported incorrectly to the projects I work on, I guarantee you I get emotional about it. All right, I am not a security researcher. I play one on TV. So this is a quick example. This is Audible. This was from a few years ago. Can anyone see the problem here? Nobody? All right. It's a pretty big coupon, right? So Audible sends coupons to you. I don't have a free month code to send anybody, but if you're an Audible subscriber, they give you coupons every once in a while. And come to find out, I could change the value in a query string. So this is pretty cool. I just changed it. And then look at that. I have $1 million coupon, right? Not really. This just updated the web page. Amazon Audible were validating that query parameter was a number. So it didn't look like there was any cross-site scripting problems, but it still updates the page. There's still a potential problem there. I probably could have tried to sell this code online maybe. I don't know, that's kind of silly, but I could have at least given their support team a bad day when somebody's mom reports it or my dad would report it, right? So is this a vulnerability? I would say yes. I would say it's a very low severity issue. And I'm going to talk about severities in a few minutes here. I reported this to Amazon. They accepted it. They didn't follow up with a fixed timeline or when they were going to get back to me. And I didn't follow up with them because I didn't care because this is a pretty trivial issue. But here's another vulnerability that's been triggered by a simple string. Has anyone seen this one? Right? Like every day in every news article and for the past year, maybe. This one makes the other one look like a toy, right? And again, I'm going to talk about severities of these issues in a few minutes, but I want to cover some basics. All right, I think there's some confusion between CVEs and vulnerabilities. I think oftentimes we use them interchangeably, but a CVE is basically just a way of describing a vulnerability across different data sources, right? You can basically just think about it as a number, as this ID, and some metadata, like the affected product, a version, some sort of description, right? These IDs are assigned by a numbering authority, like MITRE. Not everything gets a cool name, right? Not everything is going to get a cool name like Log4Shell. Most of the time, we just use this identifier. Everyone has seen these, right? Hopefully. Anyone not seen one of these identifiers before? Okay. This is typically what we talk about. So that's a CVE, right? Every once in a while, like the CVE listed on this page is not actually a vulnerability. It was reported incorrectly. If I remember right, the reporter just didn't understand what Python's virtual environment was. But most of the time, they're valid. All right, so it's scary graph time, right? Every good presentation needs a scary graph to make you worried. No, I kid. This graph does show the frequency over the last few years of new CVEs being reported. So I'm not actually showing this to scare anybody. I'm just trying to stress how common these things are, right? So this data averages out to 1,600 vulnerabilities per month. That's more than 50 a day. So just let that sink in, okay? The red line is obviously going up to the right. Just this year alone, we're averaging 70 per day. So that means these things are pretty common. We're going to see them over and over again. And I actually think this number is much, much higher. So this is just what's been reported publicly. And I know there are definitely cases that private companies and even public companies don't always create CVEs for these things. All right. So every year, more and more software goes into the world, right? That means more bugs. We talked about this. More bugs. More bugs means more security issues. That's just how numbers work. All right, so I usually skip this slide. It's kind of boring. Nobody likes definitions, right? But everybody's heard that Log4Shell scored a perfect 10. Perfect 10? Yippee? No? That's not good? All right, so this is how scores are created. So we use this terminology, common vulnerability scoring system. We like to stick the word common in front of everything possible when it comes to CVEs. This whole thing is a bit complex. You don't worry about it too much. I just want to give you an overview so you know that when you see a 10 or a high number, that you probably should be worried about it. And if you ever have to go calculate one of these scores, there's a calculator for you at that website, so it's not something you need to remember. But in general, over on the left here, we have the base metric group. So those are things that are consistent over time and environment. So the exploitability, that represents the thing that's vulnerable, and the impact represents the result of the vulnerability. So if you can get a shell from the result of an issue, that's the impact. The thing in the middle is the temporal metric group. I feel like I'm time traveling maybe, I don't know. But these are the things that change over time but not environment. So if there's a utility to exploit an issue, maybe the score goes up. If there's a fix or a patch or something, maybe it goes down. And over on the right, we have the environmental metric group. So those are the things that it's going to affect a particular user's environment. So maybe in the case of your machine or whatever, you could block a vulnerability with a firewall rule, right? So it doesn't really affect you. That was not the case with Log4Shell, but some vulnerabilities it is. All right, 2 more definitions to get out of the way, and I'm going to try to avoid mostly definitions, although I'm going to make no promises here. So the word common appears twice again, right? We like that. But the first one is an enumeration of 800 different things that classify the different types of weaknesses. This is really just so we're all using the same vocabulary. And you don't need to remember these things if you're creating a vulnerability, but if you're looking at an existing one, this will give you an idea of what you're looking at. The last one, I think, is the interesting one. This is just the name. So I think Windows XP was the last version of Windows I really used, like, consistently. So there's a bunch of information in this name, right? It's got Service Pack 3. It's got the architecture x86, which nobody uses anymore, but that was a long time ago. But the bottom one looks more familiar, right? That kind of looks like a Maven coordinate, right? Everybody familiar with Maven coordinates? So GAV, group artifact version. Those are not the same thing. If you remember nothing about the slide, they're not the same thing. There's been attempts in the past to do some fuzzy matching between the two. Everybody's seen false positives and whatnot. So I think this is kind of a flaw in the way we handle these things. Luckily, there's vendors that help out here, but and it's not just a Maven problem, right? If you're NPM or NuGet, or every package manager has the same thing. They use a different coordinate system than we use for the CPE. All right, so question. Who thinks CVEs are bad? Nobody? That's good, okay. Who thinks I'm asking a trick question? Okay, so you guys can raise your hands, that's good, okay. I am, I think CVEs are good. It's an opinion, but basically they're providing a standard way for us to talk about security issues, right? Software bugs are a fact of life, and it's how we handle them that makes them good or bad. We can handle them in a responsible way. So this is Apache Tomcat. Everyone's heard of Tomcat, I think. This is a Java conference, I hope so. So Tomcat has a security page, and they list the number of vulnerabilities, each vulnerability that affects each version of the product. And you can also just go directly to a database, so a CVE database like MITRE or NIST, to find the same information. The biggest point I'm trying to make here is you can find the information. This gives developers and system admins notice to go update and patch their systems. But there's also the bad, right? Everyone has heard horror stories of data breaches and cyber attacks and all that. We don't want our applications to be affected. The truth is, they're going to be, right? And we need to make sure we handle these things correctly. Sometimes, when these issues are announced, it means we have to put some extra time in, work over the holidays, right? Anybody have to work over the holidays last year? Everyone here was lucky. Okay, a couple, yeah, all right, a couple folks. And then thinking a few years back before that, there was Spectre. Spectre was a massive pain in the ass. Folks worked overtime, just like Log4Shell. In some cases, that decreased performance on people's machines. So you had to update your cluster sizes or whatever to increase your use larger CPUs. It costs money, right? These things are a pain. All right, so let's talk about the ideal reporting timeline for a minute. So this is how we're going to go about reporting a vulnerability. So the first thing we do is report the issue, right? I'm going to get into this in a few minutes. But we're going to report the issue privately. That's really the only word you need to remember through this whole entire talk, the word privately. All right? Once the issue has been reported privately, whoever is responsible for that product or the vendor is going to fix the issue, and they're going to patch and release some sort of fix, right? And then that issue is going to be disclosed. This is oftentimes in release notes, and there's a whole bunch of other ways that you disclose information for CVEs. But basically, everybody's updated code and they see like a security warning in a release notes or something. Think about it like that. Okay, so has anybody not heard the term responsible disclosure? Anyone who's just afraid to raise their hand? That's fine. That's totally fine. These are common terms, but they're terms that just get thrown around in certain circles, right? So I think it's kind of a fault of our industry as general that these things aren't taught in universities and schools. But anyway, so disclosure in general is the action of making secret information known. So responsible disclosure, and Microsoft and a few other folks call this coordinated disclosure, basically means you're going to keep something a secret until it can be fixed within an agreed upon time. And then there's the term full disclosure, which means tell everyone everything right away, right now. So the benefits of full disclosure is that it gives users and admins all the information they need to make their own decisions. However, it also gives attackers the same information. And in my thinking, attackers are more likely to be able to exploit an issue. Right? We saw this with Log4Shell. Right? As soon as an exploit in the wild, admins and everybody were scrambling to do something, right? Where attackers had a really easy job of trying to exploit systems. All right, so my view is responsible disclosure is almost always the best case option. It's really easy to disclose information. You can post things to Stack Overflow or whatever. Like it's trivial to get information out in the wild. It's impossible to take it back. Those things are indexed by Google or other mailing lists or whatever. You can't take it back once it's out there. So even if you think reporting an issue with a full disclosure kind of policy is better, I would still encourage you to start with the responsible disclosure. It might be a better route. You can always, include more information publicly after the fact. All right, so thinking back to my three pillars here, so we had report, fix, disclose. I think the reporting thing is really what we don't talk about. So this is really the reason why I created this whole talk. It's complicated. This step requires more work for the person reporting the issue than a regular bug. Everybody's reported some sort of bug before with Jira or some bug tracker. We all know how to do that, right? This is a little different. You can't just go to a bug tracker and fill it out, right? Because of the word privately. Each project is going to handle this differently. So you as a reporter need to go find and search out the project or the vendor's website and figure out this information. Maybe they have some kind of security mailing list. I don't know, maybe you have to go to a bug bounty site, Bugcrowd or HackerOne or something. And for smaller shops, maybe you can't find any security professional or anything. And so you email the support staff and ask them, how should I go report this? But you're just asking them how to report the issue, not actually reporting the issue yet, It requires more work. And if you're paranoid, you can always create an anonymous email account or anonymous account with some services and report the issues that way if you don't want people knowing who you are. Again, I don't worry about that, but if you are, that's fine. This is actually why I wrote this talk. Don't use a public bug tracker to report a security issue. I was talking to someone the other day, and they talked about there was an issue on GitHub that affects Xstream. I haven't read anything about that yet, but it's still an ongoing problem. So this issue is an issue I helped fix. The reporter was a security researcher. They opened this issue and then basically just ghosted us, right? Some folks will just scan a bunch of public repositories and look for a very specific issue, to gain reputation and pad their resume. I'm actually all for padding a resume. Like, if you want to be a security researcher, I get it. Like, it's a thing. You get paid for that. You want to make sure you're reporting issues. I just ask you to do it responsibly, right? You can still get that reputation, just it takes a little longer. All right, but it's not just bug trackers. I've seen the same thing on Stack Overflow and mailing lists, everything. Don't report these things, anything that seems public at all. Once it's out there, there's no going back. I've seen occasionally some projects will have like a little checkbox on their bug tracker that says, is this a security issue? And you check it and you think that's great, like that's how I should report this. I'm still wary of those things. I still think I would search out sort of proper communication channels, maybe with their security team or whatnot, before going that route. But that's up to you. My view is I don't know how their bug tracker has been configured. Anybody ever manage Jira? Okay, it's a pain. Bug trackers are a pain. Access groups are a nightmare. I don't know, maybe that's my personal bias. It still happens. So I talked about this again. There was an Xstream issue, but this was a Log4Shell issue. This issue was created before Log4Shell was fixed. Right? Once you create an issue, that triggers emails, that's out there. At this point, the information is essentially disclosed. All right, so we've reported the issue. It's private, awesome. Now we're gonna fix the issue. We all know how to fix bugs, right? Most of us do? Okay. That's cool. So if you're a reporter of a security issue, as soon as you report the issue, you can be done. You can put your feet up. You don't have to do anything else. Usually there's a little back and forth between the team fixing the issue and the reporter. But if you want to be completely done, that's fine. If it's an open source project and you want to get involved, maybe you found the issue and you know lots of details about it and you think it's a quick fix or whatever, awesome, that's great. But remember, this is going to require some special handling, right? Think back in the old days, we used to email patches around. Anybody remember that? Nobody wants to admit that? That's fine. I get it. My chin is turning white too. So you're not going to be able to send a public pull request if you want to fix these issues. Communicate with the developer team, figure out how they want to handle the issue, just work with them. Your commit messages may need to be sparse. You probably don't want to be like, I'm fixing this security issue, right? You may want to say something tangent that's related, but nobody likes doing that. But again, it may take a few days between a fix gets in your code base and it's actually released. So it's not time to disclose information yet. We're going to wait. And applying a fix means different things on different projects, right? So Java projects, we typically publish binaries, libraries, jar files to Maven Central or WAR files or however you distribute your code, right? Microsoft is going to release some sort of patch on Patch Tuesday. And there's a whole bunch of source-based projects that are just going to cut a tag. Like PHP, you just cut a tag and that's your release. That's it. All right. Anyone heard the term security embargo? This is another one of those niche terms. So security embargo is the period of time that we have between an issue has been reported and in the amount of time the development team has to fix it. So we try to keep this window as short as possible, but you still need to give time for folks to fix the issue. And recommendations of how long this window is all over the place. So Google's Project Zero, I think their default is still 90 days. They've actually published an issue as soon as 7 days. They say the issue, there was already exploit in the wild. Once there's an exploit in the wild, like Log4Shell, game over, right? You need to disclose everything at that point because attackers already have the information. But they've also waited 8 months. In the case of Spectre, everybody remember Spectre? Hopefully not, maybe. I don't know. But that was 8 months before that issue was finally leaked out. The Linux kernel is actually 19 days. I think their official number is 19 days, which is 2 weeks. And then they add a couple days for holidays because people have lives, right? So general suggestion is keep this as short as possible while still giving the vendor enough time to fix the issue. All right, so question for everybody. I know you don't like to raise your hands, but how long does it take you to fix a regular non-security bug? Days? And get it released to your customers? Days? Nobody? Weeks? Months? Right? I've definitely worked on projects that I will probably not admit that have taken months to get out, right? So think about that, right? A security issue is probably harder to deal with than some little feature. Maybe not, depending on what it is, but we need to be ready to act. Getting back to the Linux kernel, right? So Linus's fork on GitHub has like 45,000 forks, and like 140,000 stars, right? Internet points for GitHub. That's a lot of eyeballs in that project, right? So if there's a security issue, the potential of it being found is pretty high, right? Everybody heard this quote, right? 3 may keep a secret if 2 of them are dead. This is basically, the more people you add to something, the harder it is going to be to keep it a secret. So I joke, right? But think about how fast information travels in the world today. Right? We knew about Log4Shell like right away. All right, so we fixed the issue. Well, sorry, we've reported the issue privately. We fixed the issue. Now it's time to disclose the issue. So this is the first time information is going to be released to the public. So typically, the vendor handles all of this, right? Or the project. They're going to create a CVE. They're going to deal with all of the disclosure. You don't have to do any of this. That's all on the vendor. But once it's out there, if you're the reporter or you're just interested in that particular issue, feel free to go blog about it, right? Tell your friends you're a security researcher, whatever you want. Or not. Some companies will pay you to just keep your mouth shut. You know, whether you want to do that or not, it's totally up to you. All right. The Apache Software Foundation has a great detailed list of how Apache projects handle security issues. I think if I was going to create a policy at my company, this is where I would start. I've used this policy for non-Apache projects. Obviously, there's some Apache-specific bits in there, but you just tweak those to be your whatever fits your company. So I think that's a great place to start. And it literally walks you through everything. All right, I'm going to talk about Log4Shell for a minute, and I'm not trying to pick on the team, right? Getting through that issue was rough. We need to thank them, right? Don't pass judgment, at least until you've gone and helped out your favorite open source project and patched a few issues with them. These people have lives. That issue was over the holidays. That's a rough time. They have day jobs. Give everybody a break, right? With that out of the way, I do think it's important to look back and think about things and tie it into what we've been talking about. So here's another timeline, right? This one's going to look a little different. This is the story as I know it anyway. So the issue was reported by Alibaba's cloud security team to the Log4j team. So far, so good. We're in the clear. This is the same as we talked about before. Then I hinted at this before, but the Log4j team created a public bug. There were some pull requests. The ASF uses Jira. Jira sends out a bunch of emails. Those emails are in mailing lists. It gets indexed by Google. This information is now out there, right? It's essentially been disclosed. 2 days later, we have the first exploit in the wild. So we have Cloudflare mentioned this, says they found something on the first, and Cisco the next day on the second. Now, I'm not saying these two things are related. I'm not saying attackers found the PR or whatever and created the issue. This is the timeline. That issue had been in the code base for a long time. Alibaba obviously found it a few days before that, so some people were finding it. However, the information was still public. All right, so at this point, right, here's the panic. Anybody remember the panic? Yeah, coming off, Thanksgiving to Christmas. It was still a few days later. It was over a week later that a release was finally made, and then there were some follow-up releases to fix issues before they totally ripped that feature out. All right, so let's talk about what we can do for our projects. Many of us have projects, open source projects, that have public bug trackers or some sort of public-facing component. So I want to talk about what you can do for your customers or your users. So if you think back, if anyone was here, remember my title slide, I talked about, I was going to talk about code first and then your dependencies. I lied. Dependencies are more important. Anyone know why? You two don't count. I know you two don't. All right, everyone seen this? This chart? The big green circle is my dependencies. The little white dot in the middle is the actual code that of my application. right? Look at the ratio of that. That means my dependencies are more important than the code I write from a security perspective, right? All software has bugs. Security is hard. You need to be ready to be able to handle security issues. Your dependencies will have security issues. And we often, as Java developers, we typically talk about our dependencies as other libraries, right? Things we pull from Maven Central, right? But the same is true for NPM or NuGet or whatever package manager you use. But your dependencies are everything your application depends on, right? We have the obvious things like we talked about. So we have other libraries, jar files. But most Java applications run on a JVM. Anybody not? Native image, anybody? No? All right. That's a whole different topic. So maybe your JVM is running inside Docker. Your Docker's running on an OS. Maybe your OS is running on a virtual machine. This is just to get your application started, right? Maybe you have databases or caches. And then you think about if you're building web apps, a request is going to be sent from a user to your application. It's going to go through firewalls and gateways and load balancers and all of those things. So those are all your dependencies. All right, it's going to look like I'm changing topics for a minute, but I'm going to bring it back. Don't worry. Anyone affected by the CodeCove issue about a year ago? Anyone remember this? No? I'm glad you weren't. I was affected by this issue. So there's a supply chain attack. CodeCove basically lost control of their install script. And the way they have their install script, they basically just shelled, piped a curl command back to bash, and that's how they were installing the CodeCove utility on everything. So that's how your CI worked. That's how your local machines worked. It was in hindsight, that's not a good practice, right? Even at the time, we knew that wasn't a good practice. But anyway, long story short, your build software, the things that are building your software, your CI pipeline, whatever, that's still a dependency of your application. So you need to be able to be ready to handle these things. We're going to see these things. You need to be able to rotate your keys. This happened again a few weeks ago, or I don't know, a few months ago maybe, between GitHub, I think Travis, and another CI vendor. More keys are leaked. You got to be ready to rotate them. All right, and related to this, this is a pet peeve of mine. It is impossible to run a secure application on insecure hardware. Anyone disagree with that? Okay. So I've worked on a few projects recently that are still targeting Java 1.7. Does anyone know why? No? That's good. That means you're not having to deal with it. Because Android. There are folks out there, and this is getting better very recently, but there are folks out there that still want to target Android 6, which hasn't had a security release since like 2018, right? How do you expect to run your secure software on an insecure system? And I'm not picking on Android. This happens all the time. If a library that you're using isn't getting updates, you want to look for alternatives. Here's a tip. That one's free. Less vulnerabilities, write less code, right? Sort of. I don't know. I'm not talking about no-code solutions here. I'm talking about using existing components that fit your needs, right? 20-something-year-old me definitely would have laughed at this advice. I was definitely doing some cowboy coding. And to be fair to my younger self, we didn't have the things then that we do now. So today you should probably use some sort of framework that has all of these security concerns baked in, right? Spring Boot, Quarkus, Micronaut, pick your favorite, right? Security is embedded in those things, and you don't have to worry about a lot of it. All right, so I mentioned this at the beginning. I work at Okta. I don't know, I have this cool shirt. I'm not here to sell anything, so I'm not talking about that. But if you're building code that's hashing passwords or doing something similar like that, it's time to take a step back and really think about why you're doing that, spending time doing that, instead of buying something or using an open source alternative. Are your dependencies healthy? How many people regularly update their dependencies in their project? All right, that's pretty good. All right. You want to make sure that your projects have active communities, mailing list, forums, whatever, that they're getting updates. You also want to keep your dependencies to a minimum. If you're building a Spring application, right, you probably don't need to pull in Commons Lang or Guava just to use a string util class. All of that stuff is already in there. So you can save yourself one less dependency and not worry about it. We also need to think about transitive dependencies. Everybody heard that term, transitive dependency? Okay, good. When I started, that was not as common, but I'm glad everyone here has. So anyway, so these are the dependencies of my dependencies, right? This, I don't know if you can see it, it's dark, but this is a Spring Boot 3 application. My Maven POM has literally one dependency in it, and this is everything that gets pulled in. So if I'm just using one dependency, I don't have to just worry about that one dependency. I have to worry about everything in my application. And the Spring team does a great job of keeping things up to date, but it still takes them a while. After a CVE has been announced, it still takes them a few days to get things into a release. So that may or may not affect your applications, and you need to be aware of it. I really think you need to have a plan in place. So anybody using Dependabot or Sneak or any tool to automate your updates, okay? If you're not doing that, I think it's going to be almost impossible. There are other tools, like there's Dependency Check, which I think Sonotype sponsors. You need to scan your Maven or Gradle or whatever dependencies to make sure there's no vulnerabilities. There's a Maven versions plugin that you can force things to use the latest version. There's something. Whatever works for you, go try them all out. Whatever works, use that. You need to automate it. And if you're not running tests, anyone have projects that are still not that don't have tests? I wouldn't raise my hand for this one either. I totally get it. I've been in that boat. I get it. There are probably talks here this week that you can go to and bring that advice back. But you can't automatically update your dependencies if you don't know if any of those updates are going to break things. So it's all goes back into proper engineering, right? Here's another bit of advice. So if you're only scanning your main branch, anybody doing that? Just scanning your main code, right? Your master branch or whatever for vulnerabilities. But then it takes you a month to get things into production. Anybody see an issue with that? Right? Okay, so your whatever's running in production is still vulnerable for a month. Scanning just your main branch isn't going to help you that much. I mean, it's a good start, but you need to be aware that your applications that are running are still potentially vulnerable. All right, one more fact. So when Heartbleed was announced, it took Cisco 50 days to identify the software that they had built that was affected by Heartbleed, right? And it took several more weeks for them to fix it. You know, Log4Shell last year, they had all of their on-prem products fixed within 2 weeks. And they had everything identified in 2 days. Granted, those are two different class of types of issues, but it still shows the importance of a lot of this stuff just comes down to management of your applications and software. All right, in SBOM. Everybody heard of SBOM? The US government's starting to push this. Like it's going to be a thing we hear more and more about now. This is not to be confused with a Maven bomb. So an SBOM is a software bill of materials, and a Maven bomb is still a bill of materials. But in Maven, it's a dependency management tool, right? And an SBOM is basically a list of the components your application is using, so your users know what's in them. So this is the ingredients list on your breakfast cereal. When Log4Shell was announced, a friend of mine calls me up in a bit of a panic, which I'm sure some of you have similar stories. This guy is an IT director in a public school system back in New Hampshire, where I live. He was like, how do I find out if I'm vulnerable to these issues? I was like, you probably can't. I don't have any good advice for you. You can do some fancy file searching, grepping, right? But think about all the different ways that we package Java applications, right? You could have jars just laid out on a file system. You could have a jar of jars. You could have a war file, which is essentially the same thing, a zip file with other jars in it. You could have shaded jars where you pack everything in one file. You can move packages around. You can obfuscate your code so the packages aren't easily found. You can build native images now. So you turn your Java code into a native binary. It's going to be impossible to just scan a file system and find these types of issues. But something like an SBOM, maybe if he had some way to manage, all of the products that they had at their school system, they all had SBOMs, he could at least do some searching there. That's going to require a whole other suite of management and everything, but at least that would have been something he could have looked at. All right, so let's get to your code, right? I know what time is it here. So you guys want to eat. I'm going to get you out of here soon here, I promise. So the code is the small piece of your applications that you actually care about, right? You can do static analysis, you can do security audits. There's a whole bunch of suites of tools out there. OWASP is a great resource. Has anyone not heard of OWASP? Go check them out. There's a whole suite of static analysis tools. I'm a huge fan of find sec bugs. You get a little red squiggly in your IDE. There's a bunch of commercial options too, Sneak, SonarQube, Veracode. There's a whole bunch of options. I think it's one of those things that teach you more about your code as you're writing it. And it has to be while you're writing your code. If you're scanning your code after the fact, after it's been committed, it's too late. You can scan on your local machine or on your pull requests. After that, you have to go looking for that information. And at that point, you don't care. It's checked in. You've closed your Jira, like you're home, right? Vulnerabilities are a fact of life. It's really something we need to take to heart, right? I keep mentioning this, but it's worth repeating. You need to expect them. And you need to make sure you provide a way for your users to report issues to you. This could be simply as simple as a mailing list. The problem is, and this is a problem with our industry, right? This isn't a problem with my project or your project. There's no standard way of doing this. Every company does this differently, and it's painful. So you need to make it obvious to your users to figure out how to report an issue to you. And this also applies to internal software. So if you're building software for a Fortune 500 or, I don't know, if you have just 100 employees, you still need to find a way that they can report issues and report them to you. Right? Much of our software, like lots of folks have public bug trackers or anything like that, right? Some sort of public-facing component. So if you have a bug tracker, I stole this idea from Spring Security. I don't think they do this anymore, but I think this is a great idea. This is an HTML comment in their GitHub template, right? That links to, it basically says, if you have a security issue, go here instead of creating an issue on GitHub. People don't know, right? Most folks do not know that issues require special handling. That means you need to nudge them in the right direction everywhere you can. And this is a great unobtrusive way to do that. There's also security markdown files. So GitHub lets you define a security policy. Again, this is the same idea. You're essentially just creating a link and pointing people somewhere else where you have a doc that walks people through how to contact them. And this is my favorite. So anyone ever heard of security.txt? All right, go check this out. So this is a new RFC. The RFC, I think, was finalized at some point within the last year or so. It's basically just a static file you drop on your web server at the root of the server in this well-known security.txt location. And you can think about this as like a robots.txt. It's a bunch of metadata. Basically, it's just another way to help people to find where to go report issues to your company. I found an issue. It was a really silly issue on a website a few years back, and I could not find how to go report them. It was a children's toy company, but their website had a bug. Come ask me about it later, and I'll tell you about it. But I found their security.txt file before I gave up, and I was able to email the security team, and they were awesome. So this costs almost nothing. If you can drop a file on your web server, this is the easiest thing you can do, and you can do this today. All right, there's also bug bounty sites. You go create profiles over there for your products. Bugcrowd, HackerOne, all of those things, right? I would way rather pay a bug bounty than be on the front page of Hacker News, right? All right, and this is literally just the tip of the iceberg. The key thing is here is you need to be aware that security issues require special handling, and you need to be able to be ready to update them at a moment's notice. We're going to see more and more large security issues. All right, thank you. So if anybody has any questions, I can try to answer them. I know everyone wants to get to lunch, but I also have stickers over here, so come find me afterwards. But if anyone has questions, I'll try to answer them. And if you don't, I get it if you're hungry. Anybody? It's cool. I'll hang out for a few minutes. You can come ask me if you want. Awesome. Thank you.